But first, arrive at work, unlock the door, turn on the lights. Offices all over Britain use fluorescent lighting because it's cheaper and more efficient in the long run. But how does a tube full of gas light up your life? Fluorescent light bulbs start off as a large lump of hot glass. In this fluid state, the glass can be stretched and blown into a very long tube. Diamond-tipped cutters then trim the long tube down to 2-meter lengths. Occasionally the tubes break, but they're discarded and recycled. The next step is to trim the ends. Flames burning at 700 degrees Celsius create a neat fracture line, and a tiny cutter knocks the uneven ends away. Sharp edges are rounded off, and the tubes are now ready to hold the various elements that will generate light. Fluorescent bulbs are more efficient than ordinary light bulbs, making them cheaper to use and therefore more attractive to businesses. But for that economical light to glow, the inside of the tubes must be coated with phosphor, a chemical that will cause the bulb to fluoresce. Next, the internal workings of the bulb are constructed. Like an ordinary light bulb, the fluorescent tube also contains a filament, which carries an electrical charge. This filament must be put together so it can be fitted inside the phosphor-coated tube. Fluorescent bulbs work by exciting particles of gas with electricity. These particles then emit energy which can be turned into light. Once constructed, the filaments are sealed into the tubes. Now, you may have noticed a glass tube sticking out of the end of each of the larger tubes. This is where the energy-emitting gas will be injected. The gas is made out of mercury, a toxic liquid metal used in a range of everyday objects from batteries to hospital thermometers. Mercury is recycled from these items and collected in a facility like this one. It's a dangerous process and the scientists have to be careful. While handling mercury is a hazardous job that requires a gas mask, the liquid metal can be collected in an ordinary bucket, and a simple trick using water keeps it safe. Mercury vapor is the gas that creates light in the fluorescent tubes, but it's dangerous if inhaled in large quantities. Storing mercury beneath a layer of water stops it vaporizing. Now, if you're worried about the gas in the tubes, don't panic. The amounts used in fluorescent lighting are so small, they are not considered very dangerous. The bulbs are now ready to be injected with the mercury vapor. The tubes and mercury are loaded into the filling machine. The mercury is heated, which vaporizes it, and this is injected into the tubes. The heat causes the gas to release energy, and this makes the bulbs glow, even though they're not connected to a power supply. So how do electricity, mercury gas, and the phosphor coating create fluorescent light? We already know that there are filaments inside the gas-filled tube. They send out electrons from one end to the other, which strike the gas particles floating in between. This excites the gas, which in turn emits radiation. But radiation is invisible. And that's where the phosphor coating becomes important. It wasn't to color the tube. The phosphor fluoresces or glows when bombarded with radiation, and this glow is what lights your office. With the insides now phosphor-coated, filament-fitted and gas-filled, all the tubes need are the external caps so they can be fitted into lamp holders. The caps are carefully fed over the filaments, sealed into place, and the job is done. Finally, the bulbs are passed through a tester where any that don't work can be spotted before they're sent out to the stores. Although streetlights were originally powered with gas, the emissions probably wouldn't pass modern standards. But today we can still see, thanks to cleaner, greener, gas-powered technology. the fluorescent light.